Hi everybody, I'm Florent Garin, the founder of DocDoku. Today I will present you our projects, DocDokuPLM, and especially a feature, the Digital MockUp visualization feature. So just before the demo, perhaps I don't know if lots of people know what PLM is. PLM stands for Product Lifecycle Management. So it's about, it's a software, a middleware software that's aimed at managing all the information around a product. By product, I mean a manufactured product. So that could be a bicycle, that could be an airplane, a mobile phone, everything that can be made. So a PLM software objective is to gather in a central point every information around this product. So all the information are kept here around all its life cycle, from the idea to its disposal. So the idea, we start with the idea. Some people in the company can have an idea of a new product. He can write some Word documents, or some PowerPoint document. After that, another engineer can design the product with a CAD authoring tool. A marketing guy can then make some video to show the product. And after that, you have the idea. So our project is that, to gather all the information of a product to bring, the main objective is to reduce the time to market, so, and to increase efficiency. So what's our key features? We can divide our product in three modules. The first module is the product management by itself. So this is what I will show you today. With this model, you can browse the product structure. So I will explain you exactly what is the product structure. A product is managed under configuration, so I will explain you also that. Another model is the document management model, which is more classical DM, like what we can have using Nuxeo, for instance, but it's not almost the same, except that we follow the step 10,303, which is ISO standard for PLM and product definition. So, for instance, this standard define what is a document master, what is a document version iteration, how change around document have to be tracked extra. And after that, a big part of PLM system is change management, because we should keep a trace on every single modification that happen on a document or on the product itself, and we have also to carefully manage change made on product. We can easily understand that if Airbus made a change on a change design on a specific aircraft, they have to keep that information and to know exactly when this change happened, who decided, and what are all the consequences on that change. So the change management is a key features of our PLM software. So today, I will concentrate my demonstration on the product management module. So at the out of the product management structure, there's the product structure. So what's a product structure? A product is divided in assemblies and parts. For example, a computer is in computer you have a motherboard. After that, you have a different card plugged into. You have the video card. You have the hard disk. Okay, so this is the same for every product. Every product is made of assemblies, and assemblies are made of parts. So the product structure is a representation of this breakdown. Okay, and this breakdown, this product structure is managed under configuration. That means we can make the parallel of software configuration. If you use SVN, Git, or any software configuration management, you know what I'm talking about. This is exactly the same. And this, in the industry, manufacturer need to manage all the involvement of their product. So this is a sample of a product structure. This is how we represent a product structure. At the top, you can see part number 100. This is the product itself. Below we have revision A. Okay, revision is a major evolution of a part. Okay, minor change are not represented here. Minor change is what we call iteration. Okay, so this is vision A or product 100. This product is made of two assembly 200 and assembly 300. Assembly 200 has two versions, A and B. Okay, so the question is, which one should we choose when this product go to the will be made? We have to decide which one will be used, and this question is answered by what we call effectivities. This is effectivities. Effectivities has to be read like this. If we made product 100 and we made this is the serial number. We made product serial number 1, 2, 5. We'll choose version A. After, when we starting from serial number 6, so if it's an aircraft, the 5 first airplane will be made with version A, and from serial number 6 we introduce a change, and now we made the aircraft with version B. Okay, this is how a product is managed under configuration. This is the standard way to do it in the industry, and effectivities could be expressed. Could be based on serial number. This is the case here, but also we can express effectivities under with date or law, if we make a production based on law. Okay, let's jump into the demo. I just log into the system. Just a product. On the left, I can see all the product breakdown. This is the head of the product. Below, you can see, okay, subparts. This is the doors. So I can check some element here. And, okay, you can see, this is the door of, this is an aircraft. Okay, so I can see all the doors of the aircraft. Okay, everything is running under a regular browser. Okay, we use HTML5, a bunch of JavaScript to display it. Okay, so this is what we call the DMU, Digital MockUp. Okay, this is another door. Okay, I will uncheck this, and I can check and uncheck element on the product. So this will loading the whole aircraft. I can show you. Okay. Be able to display the digital mockup was a huge challenge because just imagine the biggest aircraft in the world, the A380, is around 1,002,000 parts. 1 million parts. I'm talking about parts, not instance, because usually one part is duplicated. Imagine a screw is, you can find a screw in many instances in the aircraft. So we have to, that's more challenging than a video game, for instance. So we use lots of optimization algorithm, frustum culling optimism algorithm, that the frustum culling elements parts that is not visible. We load and unload parts as we move around the visualization. Okay, that was very difficult. So we have lots of algorithm. We compute the bonding sphere radius and to determine if a part have to be shown or not, and we dynamically change the level of detail. So we, as you can see, it's a breakdown. You can select exactly what you want to see. I will check this is the noise. If I click on, this is an assembly, I can have the details of this part. And I can see if this instance, there's only one instance of this part. Some are, okay, duplicated, so I will check all the noise to show you. We also have to struggle with the limitation of the browser, because in Chrome we cannot allocate more than 1 giga, 1.5 giga. So it's also very difficult to achieve this. So every time you have we switch from the quality, it's very challenging. But at the end of the day, that works. And okay. Okay, apart from that, I can also create layer and pin some information exactly as Google Maps. So I create clashes. Clashes is when two parts cannot fit together because the dimensions are not, that doesn't fit. So I can create, for instance, a marker, okay, clashes number 1 and fill a description. So now I just attach a pin on my model. I can even switch to this is what we call, okay, so I have to select a part before. I can export my model exactly like Dailymotion or YouTube. So I can, this is an iframe, I can include my model and post it in XWiki or any other blog or what tool we want, and we can share also all the marker information. Okay, so there's lots of other things to say. This model is managed under configuration. For the demonstration, just select the latest version, so we can see the latest version, but I could have select, okay, airplane serial 2, serial 2 or 3, okay. Okay, there's something we didn't discuss about is what was the source of the model. You didn't ask, but what we can see is directly taken from Katia, which is the authoring tool they use. So it's also a big part because we have to make lots of big conversion chain to convert the CATIA native proprietary format to JSON JavaScript representation of the model.